Welcome to Chemistry with Caroline. In this video, we're going to look at how to name carboxylic acids. So in terms of priority, carboxylic acid groups are a pretty high priority. The more highly oxidized that functional group is, the higher the priority. So the carboxylic acid will be a higher priority than aldehydes and ketones. So remember that the aldehyde, because it's always at the end, is a higher priority group than the ketone. Then you've got amines. Then you've got alkynes and alkenes, and then lastly you have alkyl groups and halogens as substituents. So this is the highest priority group there is. You replace the E at the end with oic, and then there's a space and the word acid. We don't typically use locants with carboxylic acids because they have to be terminal, so we know by definition that they're at the end of the chain. Let's go to the next page and we'll look at a specific example. Okay, so here I just have a simple chain with a carboxylic acid, no other functional groups. I would start numbering at the carboxylic acid carbon. This is a 4-carbon chain, so the root name would be bute, right? And this would be called butanoic acid. So instead of the E at the end of butane, I have that oic and then a space in the word acid. I don't need to put a locant because it has to be at the end. In this example, I've included an alkene. So we're going to have two functional groups, and they both change the end of the root name. So we're going to look at how we do that. We'd start numbering at the carboxylic acid, which is the highest priority. The other thing we need to pay attention to is stereochemistry with respect to the alkene. This alkene has an E stereochemistry, so I'm going to put E out in front. I don't need to put a locant because there's only one double bond, so we would know where it was. So E, and then it's going to be pent, and I like to put the locant right before the modifier just for clarity. So this would be 2-ene, and then instead of that last E, oic acid. So the ene tells me that I have a double bond, and the 2 tells me where it is. And then the oic acid tells me that I have this carboxylic acid functional group. And again, there's no locant because I know it has to be at the end, and it's the one position because it's the highest priority group. In this example, I have a carboxylic acid substituent on my ring. You name a little differently when the carboxylic acid is on a ring. It's the entire ring name, carboxylic acid. So we're going to start numbering at that carboxylic acid, which is the highest priority group. We'll number around clockwise, so the chlorine gets the lowest priority number, so 3. And so I would start and say 3-chloro, and that goes right into the entire ring name. So that's a cyclohexane. So this is cyclohexane, and that is right up against the word carboxylic. And then there's a space and the word acid. So as usual, our substituents go out in front. We have a locant and then what the substituent is. The parent name when there's a ring is the entire name of the ring, cyclohexane, attached directly to the word carboxylic, and then there's a space like we've seen in the previous examples and the word acid. So this molecule is 3-chlorocyclohexane carboxylic acid. So lastly, we'll look at what happens when you have more than one carboxylic acid. So on a chain, you would have 2 ends. So you could just have 2 possible carboxylic acids. They're both on the ends. So since we know how long the chain is, we know where they are. And again, we don't need to put locants. This is a 4-carbon chain here. So the parent name would come from bute. When there are 2 of the same group on the ends, then we're going to leave that E on the end. So it would be butane and then dioic space and then acid. So the bute tells me that there are 4 total carbons in my chain. The di tells me that I have 2 of my carboxylic acid functional group. And again, those have to be at the end because they have the 3 bonds to oxygen, a double bond, and the OH. So that's the only place they can be. So we don't use locants. This has been a look at how to name carboxylic acids. If you found this video helpful, please like, subscribe, and share with your friends. Thanks.